grade 11, grade 12, Fiscal Sciences. I welcome you to today's lesson. We are going to look at component method. This method is very useful when we are asked to calculate the y component or the x component. You can see that the diagram that I have drawn is a right-angled triangle where you can see the three sides. Rx, which is the x component, Ry, which is the y component, and R, which is the resultant. So the component method use the following formulas. These two formulas, Rx equals to R cos x, Ry equals to R sin x. So I want to show you how we arrived at these two formulas. Remember the trig ratios in maths, the cos, sine, and tan. For us to arrive at Rx equals to R cos theta, we first used cos theta. We know that cos is adjacent over hypotenuse. My adjacent in this case is Rx, which is the x component, and the hypotenuse is R. If I do the cross multiplication between cos theta over 1 and Rx over R, we get the following. We get Rx equals to R cos theta. The same will happen if we want to arrive at this formula, which is Ry equals to R sine theta. Sine theta is opposite over adjacent. No, it's opposite over a hypotenuse, not adjacent. Sine theta is opposite over hypotenuse. It will be Ry over R. And if we do the cross multiplication here, we'll arrive at Ry equals to R sine theta. So I want to show you another simple way of remembering these two formulas that are very useful when doing the component method. Let's come back to this right-angled triangle. So the side which is adjacent to angle theta, the side which is adjacent to angle theta in this case is Rx. This the formula of finding Rx will include a cos. For the side which is adjacent to angle theta, its formula will contain cos. Rx equals to R cos theta. For the side which is opposite to angle theta, its formula will contain sine. And we check the formula here, Ry equals to R sine theta. So this way of remembering this is very useful because your right angle triangle will not be positioned in this way all the time. So if you know that the side which is opposite to angle theta will contain sine, and the side which is adjacent to angle theta will contain cos, no matter how the right angle triangle is positioned, you will be able to come with these two formulas, because the only difference here is that one contain cos and another one contain sine. So let's look at this triangle, which is, it looks like it's upside down. And if you use the this memory aid that I just gave you of using the angle, it will be very easy for you to come with the right formula. For example, the formula for finding Rx. This Rx is adjacent to angle theta. We know that it will contain cos, and then the Ry is opposite to theta. It will contain sine. So we are going to look at two examples to or so that we'll be able to use the knowledge that we have just acquired. Let's look at example 1. A force of 250 Newton. A force of 250 Newton, yes, the force, acts at an angle of 30 degrees to the positive x-axis. Resolve this force into components parallel to the x and y axis. In other words, we are required to find the x component and the y component. Let's start by finding the x component. I've named it Rx. The formula for finding this x component, because it is adjacent to the angle, it will contain cos. You can see that I've written Rx equals to R cos theta. The value of R is 250. I've put 250 here. Cos 30. Here in place of theta, I've put 30. And then using the calculator, we will get the following answer. I want to put my calculator here and show you how we get the answer. 250 cos 30. 250 cos 30, it gives us the following: 216,506, and then I just took two numbers after comma, which gives me 216,51. Now let's calculate the y component. How do I come with the formula for calculating y component? This side that I'm looking for is opposite to the angle. If it is opposite to the angle, we know that it will contain sine. So my formula is Ry equals to R sine theta. We already know that R is 250 and then theta is 30. We use the calculator. You press 250 sine 30, you'll get 125 as the value of your y component. Let's go to number 2. A force of 5 Newton acts at an angle of 45 degrees to the positive y-axis. Resolve this force into components parallel to the x and y axis. Again, here we are required to calculate the x component and the y component. The formula for calculating x component, this x component or this side is adjacent to the angle that were given here. So it will contain cos. Here's the formula. Rx equals to r cos theta. Substitution 5 cos 45. Pressing these numbers as they are, 5 cos 45, we get 3,54. What about the y component? This side is opposite to the angle, so the formula will contain sine. Here is my formula, ry equals to r sine theta. Substitution 5 sine 45. Our answer is 3,54. So this is how we use the component method to calculate the x component and the y component.